Okay, grade 9, here is lesson number 4. Our second type of bonding would be covalent bonds which form molecular compounds. So here's your template for today. Please make sure you take a minute, draw it out. Okay, and let's start with covalent bonds. So covalent bonds is the case where none of the atoms involved in that particular bond are actually able to take electrons. They're not able to pull electrons to a different atom, and therefore what happens is they end up sharing electrons. And of course, we're talking about valence electrons here, not any other electrons, and they will share to have a full octet. So here I have oxygen sharing with 2 hydrogens to make water. And notice I have the electrons here. There's one from oxygen, one from hydrogen, they're sharing. And here I have nitrogens sharing pairs of electrons as well to become stable, because none of the atoms in those compounds are strong enough to pull the electrons away from the other. So what does this tell us about their electronegativity of those particular atoms involved in a covalent bond? Well, if it's not strong enough to pull apart, it must be that their electronegativities are fairly similar to each other for the different elements involved. Why do you think these are called covalent bonds? And what type of elements are involved? Look at your periodic table. What kind of elements are involved here? Hopefully you're going to see the examples here, water and nitrogen, that these are all non-metals. So non-metals are involved in covalent bonds. And they're called covalent because valent is referring to the valence orbital with the valence electrons, and co is the sharing. So they're overlapping and sharing their valence orbitals. Okay, now sometimes this happens where we have 2 atoms of the same element that are going to share electrons to become stable, and that's called a diatomic molecule. So here's an example here of diatomic nitrogen sharing electron pairs. And the elements that do this are listed here: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine are the 7 diatomic elements that will form pairs of 2 of them just to make sure everybody's stable. And of course, it's exactly the same element. There's no atom is stronger than the other to pull the electrons away, so we end up having a covalent bond. So just a reminder here, if we look at our electronegativity table, that all these non-metals are pretty similar. If we look at oxygen, 3.44, hydrogen, 2.02, not big enough difference to steal an electron. Okay, whereas if we look at like sodium, 0.93, and chlorine, that's a big difference, right? It's an ionic compound formed here and here. But if I was to do a different compound with chlorine, it's not going to be like if I pick maybe oxygen and chlorine, that's a lot more close. They're not going to be able to steal electrons from each other. Okay, so covalent bonds are capable of forming double, single, or triple bonds. So the ionic bonds, that's the number of electrons being given or taken makes it a double, single, triple bond. In covalent bonds, it's the number of electrons being shared. But when it's just a single electron being shared, it's about a pair of electrons being shared. Okay, so this looks like the number of shared electrons. Sorry guys, I got a typo here. Okay, the number of electrons being shared in covalent bonds is a lot different, is the indicator of how strong the bond is, or how many single, double, or triple bond. Okay, so 1 shared electron pair is a single bond, 2 is a double bond, 3 is triple bond. So if we look here at the diagram, here I have a single bond, 1 electron pair, 1 from each hydrogen being shared. Here's double bond, 2 electrons from each oxygen being shared, makes a double bond, and nitrogen, 3 electrons from each nitrogen being shared. And we show that as 3 lines for triple, 2 lines for a double, and 1 line for a single. We can do them just as lines, or we can do a mix of dots and dashes. That's the Lewis dot diagram. So you can do this kind here, where you do all dots to show how many electrons are being shared, or you can do lines. My preference is to do a mix of both. So I can show the bond with just the lines, but any extra valence electrons that aren't being paired up just go on the outside as dots. This is my preferred way to show it. So draw this, please, in your second box. Okay, let's talk about molecular compounds. So covalent bonds are a lot weaker than ionic bonds, and that's because the attractive forces between the atoms are a lot weaker. So remember, in ionic bonds, we have opposite charges and they're attracted to each other, whereas in covalent, they're not attracted, they're just sharing to become stable. I often think of it as like ionic compounds, like a boyfriend and girlfriend, they want to be together, whereas in a molecular compound, it's like siblings who have to share. Okay, so because of this, molecular compounds have a much lower melting point and boiling point than ionic compounds. It takes a lot less energy to break those bonds because they are weaker bonds, so it's not as strong of an attraction. Some molecular compounds can be gases at room temperature, and because these are neutral compounds, there's no ions involved here, they're not conductors with electricity as a solid or as a liquid. Here's a nice little T-chart you can copy if you want to help you with comparing ionic and molecular compounds. Okay, so how do we name these molecular compounds? It's a lot more complicated than it is with ionic compounds, but not too bad. We're going to start with the simpler ones, and we'll add some more later on as need be. So, since molecular compounds, they have a variety of bonds, and just by knowing the two elements involved is not enough to know how many are required to make it stable, because there's lots of possible ways it could combine. So because of that, we have to use a prefix. And these are the prefixes here we're going to use, and that's how we communicate how many of each atom are in the compound. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are our prefixes. So in a binary compound, which only has two elements, we're going to start with those. Such as N2O, you have to do the following steps. Step 1, name the first element. So N2O, nitrogen. Name the second element, changing the ending to IDE. So oxygen becomes oxide, nitrogen, oxide. Then we add prefixes to indicate the number of atoms involved. So it would be dinitrogen monoxide. Now if you have a if you have a single one for the first element in your compound, so if there's only one nitrogen here, we wouldn't put mono. Okay, if there's no prefix in the first one, we just assume it's one. Okay, so here's some practice questions for you. Here are the different formulas I'm giving you of these molecular compounds. You're going to draw a Lewis dot diagram. You can draw it like this, or you can draw two lines here and just draw the extra valence electrons on the side. A structural diagram with no dots, just the bonds. Describe the bonds and name it. Okay, so there's 6 of these for you to do. Practice. And again, do it clearly in a book and upload a good picture so we can give you feedback. You also are going to practice just naming and formulas back and forth. And to do that, I put together a worksheet for you. And you can just write the question 1A in your notebook so we can make sure we give you feedback on it. Okay, so write the formulas for the following molecules, which ones are ionic, which ones are molecular. Write the formulas for these ones, name these ones. Name these molecular compounds, write the formulas. It's a little more complicated one, but you guys can do this. And then here, name them. Okay, so that's your practice along with the table. This is going to get much better with practice. Practice is really important for this skill set of naming and building and drawing compounds. So your homework is to upload a copy of your notes, of course, which includes your practice drawing and naming molecular compounds, as well as the practice sheet. You need to write that information in your notebook or maybe on a separate page, and then make sure with the question numbers and upload it so we can give you feedback. We'll go over them in class together. Okay, guys, take care. You'll be expecting another lesson before next week, so hopefully pretty soon we'll be putting up for you guys. Take care.